Hello everyone, welcome to Chemazon-Complete Chemistry. So this is another question from December 2023 chemistry paper. So the Hamiltonian operator is given. What is H bar? H cap. H cap is what? It is a Hamiltonian operator. Okay, Hamiltonian operator. What does it indicate? It is a total energy operator. It represents the total energy of a particular system. So it is also called as a total energy operator. Now what is Px? P is what? P is momentum. Okay. Linear momentum. Operator for momentum. Okay. How do you get this P square by 2m? If you see, this is what? This is total energy is kinetic energy plus potential energy. So this is the potential energy Vx. Okay. And this is the kinetic energy. Okay. If you remember, how do you get kinetic energy expression? Half mv square. Then you multiply both the numerator and denominator by m. So this will become mv the whole square divided by 2m. And what is mv? mv is linear momentum. So that's how we get this expression of p square by 2m. This is along x, so it is px cap square by 2m. This is kinetic energy. K is what? Kinetic energy. Okay, this is given to us. Okay, even if it is not given, we must know this expression. Okay, it is total energy operator. Next, what we have to find out is the commutation value. This square bracket means we have to calculate the commutation value. Okay, between what? H is the total energy operator or Hamiltonian and the linear momentum. So let us calculate H cap, okay, Px cap. Here there is comma. Okay, so how do you write this expression? H cap into Px cap. So if I write down the general property, it is A cap commuting with B cap. This will be A cap into B cap minus B cap into A cap. So this will be H cap into Px minus Px into H cap. So substitute the values. What is H cap? Px square A cap by 2m plus Vx. Okay, so before applying this property, we can directly substitute and simplify this. Okay, and this is Px cap. Okay, so this, how will I simplify this? This will be Px square by 2m, okay, commuting with Px cap plus Vx into Px cap. Now 2m is what? It is constant. So that I can take outside. Px square into Px. Okay, commuting with Px plus Vx into Px cap. Okay, further if I solve this, what I will get? Now this Px square. Okay, so what we do is normally we take the derivative of this Px square, the higher power. Here it is 2, here it is 1. So we take the derivative of this. So this will be what? The value of this will be 2 into Px cap into Px cap. Now P2 is constant, so I can take that outside, divide by 2m. Okay, minus, sorry, this is minus. Okay, now we are multiplying, so it will be plus, correct. So plus Vx into Px cap. Okay, so now we know this, when a value always commutes with itself, this value will be what? This will be 0. When a particular operator, that will always commute with itself, so the value will be 0. Okay, so this and 0 into this entire term, this will be 0 plus Vx into Px cap. And what is the value for the observable of linear momentum? That is, you have to remember, that is what? Minus I h cross, minus I is what? Iota, minus iota h cross del by del x. This is the observable value for linear momentum. So this we can rearrange and write minus I h cross del by del x into Vx. So if I want to write down in terms of not the partial derivative, the complete derivative, if I want to write down, it will be minus I h cross dvx by dx. Okay, this is going to be the final answer. So what is the correct answer? Minus, okay, you can see minus iota h cross dvx by dx. So the correct answer will be what? Option 1. Okay, the correct answer is what? Option 1. So I hope you have understood all the steps. First, what we did, we just substituted the value of a total energy operator that was given, and then we multiplied this. Okay, we use the property of the operators, multiplicative property, and then when every operator commutes with itself, that means the value will be 0. So 0 into this 2 gets cancelled. So 0 into 1 by m will be 0 plus Vx into this. So then we substitute the value of Px and we get the final answer. Okay, so I hope you have understood this solution. Thank you.